right, this is just a real quick run through about ionic bonding with transition metals. So this looks just like the other sheet that we had. And the thing about this one here is you have transition metals. So if you remember on transition metals, on your periodic table, we'll put this on here, the periodic table, the transition metals are right here. These ones that we said the oxidation numbers will vary, the same ones that the valence electrons will also vary. So that's the ones we're talking about. There are also some exceptions to that rule. Gallium is one of them over here. Tin is one of them. Lead. Those are kind of the most common ones that you see that can change. Aluminum sometimes as well, just depending. So some of these metals underneath here will also be, they act like a transition metal. So sometimes you see those listed as well. So again, we're going to talk about how these oxidation numbers vary. So let's go through this really quickly. So right here we're talking about ionic bonds, or bonds made between elements due to their charges. We've talked about that in class. And ionic bonds occur between metals and nonmetals. So you always have a metal and a nonmetal. Metals are your positive ions because they're giving away. Nonmetals are negative because they are taking. So then, you know, transition metals will always have a positive oxidation number because all metals are always positive, but usually between the numbers 1 and 4. There are times when you can see that they have a 5, or sometimes even possibly 6. Not usually. So most of the time they're between 1 and 4. So what I did down here is to show you how that you know what their oxidation number is. So what they're going to do is they're going to give this noted in Roman numerals. So your Roman numeral is your oxidation number. Okay, so that's your charge. So I've given you some examples. If it says 10 or 10 with a 1, Roman numeral 1, it has a positive 1 charge. 10 with a Roman numeral 2 has a positive 2 charge. 10 with a Roman numeral 3 has a positive 3 charge. 10 with a Roman numeral 4, notice 4 is IV, has a 4 charge. If by chance you see a 5 looks like a V, so that is a 5, that's a plus 5. And then a VI, if by chance, is a plus 6. Those do happen, just really, really rare. So it's not impossible. It just doesn't, you don't see those very often. But the same thing. So that Roman numeral means their charge. So down here, we did the ion notation. So when I see iron 3, the ion notation would be Fe positive 3. Titanium 4, because this is IV, titanium positive 4. Notice they're all positive. Manganese, Mn, and it tells me positive 2, positive 2. Tin, this one doesn't have 1, so we're going to assume that that's a 1. So Sn plus 1. Sn is the symbol for tin. Cobalt plus 3. Chromium plus 2. Lead plus 2. Copper, that's a positive 1. Copper, that's a positive 4. Silver, that's a positive 3. Mercury, that's a positive 2. Manganese, that doesn't have a Roman numeral, so that's a positive 1. You assume that that's a 1. Zinc, that's a positive 4. Cobalt, positive 2. Pretty easy. All right, because they have to give those to you. Now, the next thing is, just like we did yesterday, going through this really, really quickly, you have some steps that are given to you to find the chemical formula when you're given the ionic name. So this is using transition metals. So you're going to identify the elements, get their oxidation numbers, and then use subscripts to balance. What we call that crisscross applesauce. So we've got gallium and arsenic. Gallium has a, we don't know because gallium is it acts like a transition metal. So arsenic is a -3. So gallium would have to be a +3. Okay, so what you have to do here is gallium arsenide would be GaAs. Okay, tin for selenide. Selenide. I don't know really how to say that real well. I don't do well with that one. But tin is Sn and it has a +4 charge. The reason it has a +4 charge is because it tells me it has a +4 charge. Selenium has a, let's see, it has a -2 charge. there. So I have to get those to balance. If you do the crisscross applesauce, you're going to end up with SN2, SE4, and remember that can be reduced. So this is going to be SN, SE2, because I could divide both of those subscripts by 2. Just like if that were a fraction, 2/4 and a fraction reduces to 1/2. All right, so let's continue. I have to pause it for just a second. All right, so we are at this one, copper 1 phosphide. So copper is Cu. It has a +1 charge because it tells me in the Roman numeral. Phosphorus is P, and it has a -3 charge. Got that from the periodic table. So what I have to do, crisscross applesauce. The 1 comes here, the 3 comes here, and the 3 becomes positive, remember, because we don't bring the charge down with it. So this is going to be Cu3P. Now I'm going to leave the 1 off because if it's a 1, you don't have to put the 1. All right, let's look here. Cobalt 3, that's a 3+ charge. Oxygen has a -2 charge. So I have to do crisscross applesauce. So 2 and 3. So I end up with CO2O3. All right, lead 2 nitride, Pb is lead. It has a +2 charge because it tells me, and nitrogen has a -3 charge. So we're going to do the same thing, very similar to the numbers up here. I'm going to bring this one down to 2 and this one down to 3. So I'm going to end up with Pb3 N2. All right, silver bromide. Silver is Ag. Bromine, that's going to be a +1 because it doesn't tell me. And then bromine is a -1. So those are already balanced. So I'm going to end up with AgBr. That's my chemical formula. All right, let's flip over to the back. And up here we have some, whoops, let's bring that down so you can see it. All right, over on the back, we're going backwards now. So if I give you the formula, you have to give me the name, right? So first thing that I have to do, it tells me to identify the elements. So here's this example. So I have vanadium and sulfur. Remember, since it's bonded, becomes sulfide. Put this up like so. Sulfide. Okay, now I left a blank right there so that we can fill in the Roman numeral, because vanadium is a transition metal. Okay, so if I've got sulfide, the next thing I have to do is I determine step 2, determine the oxidation number of the second element. So sulfur is my second element. So I go to my periodic table and I find out that sulfur has a -2 charge. Okay, so again, I'm looking at V2S3. So this has a -2 charge. So if I look at this as 2 sides, this side over here has a -6 charge overall, because I have 3 atoms of sulfur. Each atom has a -2 charge. Okay, so I need this side over here to have a +6 charge. So in order to do that, I have to figure out what the oxidation number is, what the charge is for vanadium. That's what I don't know, but I do know I have 2 atoms. So basically I'm trying to figure out 2 times my box is going to give me +6, because I need this side to have a +6 charge to cancel out. If I have a +6 and a -6, I've zeroed out and am neutral, and that's what I need. So obviously, hopefully, you're here and you can say, oh, that's 3. So it's got to be a +3. So this is going to be a +3. So when I write it out, that Roman numeral is going to be 3. So I'm going to put the 3 in. So that's vanadium 3 sulfide. All right, let's come over here to iron chloride. So I know I have iron, and I know I have chlorine, which when it bonds, it becomes a chloride. All right, so if I look at the formula, I have to determine, remember I'm going to Step 2, I'm going to determine the oxidation number of the second element, and chlorine is a -1, right? So again, I've got two sides of this compound. I've got the iron side and the chlorine side. So my chlorine side is going to have an overall charge of a -2, because 2 times -1 is a -2 charge. So I need this side over here to have a +2 charge. That's what I'm looking for. I got to figure out how to get that. So Fe, I only have 1, so I need to know 1 times what number, oxidation number, is going to give me a +2. So 1 times 2 is going to give me a +2. So this is a +2 charge. So when I go to write the name, I have to put the 2 in Roman numerals. All right, let's look at nickel sulfide. So because nickel is a transition metal, I know that I have to figure out that oxidation number and that Roman numeral that goes in between. So let's take a closer look at what we have. Okay, so sulfur, remember we just saw it up here, that's a -2 charge. So I have my two sides. So this overall, 3 times the -2 is going to give me -6. So I want to come up with a +6 on this side. So 2 times something, that something is what I need to know to give me a +6. And that's going to be a +3. So when I go to write it down, I have to do this as nickel 3 sulfide. Over here we've got copper iodide. Alright, so I know Cu(I)2 is the formula. So I go to my periodic table and I say, okay, the oxidation number for iodine is -1. So again, I've got two atoms, both with -1 charges, is going to give me a -2 charge on this side. So I need a +2 charge on this side. So I have, in this case, I have 1 atom of copper times something is going to give me a +2. I need this to be that number. So that's going to be a 2. That's going to be a 2. Those are both positive. So this is going to be copper 2 iodide. It needs to have a 2 charge. All right, on this side here, we've got tin selenide, because that's selenium. So I've got tin and I've got selenium. Those are my 2. So then I go to my periodic table and find the oxidation number of selenium, which is a -2. So over here I've got 2 atoms of selenium, both with -2 charges, gives me a -4 charge on this side of my molecule, or my compound. On this side I only have 1 atom of tin times whatever that oxidation number is that I don't know, and it needs to give me a +4. So 1 times 4 is +4. So this is going to be 4, and we write 4IV. So 10,4 selenide. So we got iron and sulfide, or sulfur, so that becomes iron sulfide. And I got to figure out what that number is. So I'm going to take a closer look at my chemical formula. I have to get the oxidation number of sulfur, which is a -2. Right? So in this case I have 1 atom, because there's no subscript, so 1 atom at a -2 charge is going to give this side a total of a -2 charge. So I need this side to have a +2 charge. So again, I only have 1 atom of iron times a charge to give me +2. So that means that I have to do a +2. So there's iron 2 sulfide. So that's how I figured that out. All right, so what you have for homework, what we did is this page right here, and it looks very similar to the other page, but at the top it's ionic compounds with transition metals. So that's the difference. The other one was just ionic compounds, basic practice. So we're going to complete this And I've got the answer key when you complete it. If you want to come and see me, actually I'll just put the answer key up right here, because that way if you are out. But if you don't have this, or if you haven't done it, I would prefer that you do it on your own and then try to come back and check your answers. All right, and then come and ask me, or come to tutoring if you have any questions, or come to homeroom, either one. So here's the answers. I'm gonna just put it up here and center it, and then I want you to pause the video to get the answers to check. So there are your formulas. This is a 2 over here, and this is a cobalt, CO2O3, and this is a 2. I don't know if you can see that. This is my copy, so I was kind of work in progress. All right, once you have those, then there's the bottom. So pause that and get your answers. If you have any questions, come and see me or Miss Guy or anybody else. Mr. Davis, Mr. Young, all would work.